The scale of everything. One continuous fall from the edge of the cosmos all the way down to a single quark. We're only going one direction tonight. Smaller. We'll start as far out as it's possible to see and dive inward through galaxies, through stars, through atoms, 60 powers of 10, without stopping. Keep your eye out for the one place where you appear. This is the whole observable universe, about 93 billion light years across. Its light has been racing toward us for almost 14 billion years. There's no edge and no centre out here. This is simply as far as seeing can reach. Now let's fall in. Drop closer, and the galaxies aren't scattered at random. They hang along glowing threads, the cosmic web vast filaments wrapped around bubbles of near-perfect emptiness. From here, the universe looks almost alive, like a brain mid-thought. Pick one bright knot and dive. Inside that knot is our home supercluster, Laniakea, 520 million light-years wide, holding the better part of 100,000 galaxies. Every one of them, ours included, is drifting toward the same distant point. Keep falling. Closer still, the local group, a family of around 80 galaxies. 2 of them tower over the rest, our Milky Way, and Andromeda is coming for us. In a few billion years, the 2 will collide and merge. But let's drop into ours. Here it is, the Milky Way, 100,000 light years across, spinning with somewhere between 1 and 400 billion stars. Almost every point of light is a sun, and we're about to dive into just one of them. We don't live near that blazing core. Home is out in a quiet minor arm, the Orion Arm. From here, light needs 100,000 years just to cross the galaxy, falling further in. Our little corner. The nearby stars look crowded, but that's a trick of distance between any 2 of them, lie trillions of kilometres of nothing. Space, it turns out, is almost entirely empty. The closest of them all is Proxima Centauri, 4.24 light-years away. Close. On a map of the galaxy, but our fastest spacecraft would need 73,000 years to reach it. Now, back to our own star and the worlds around it. First, we cross the true edge of our solar system, not Neptune, but the Oort cloud, a giant spherical shell of frozen comets that may reach almost a light-year out, the last outpost of the sun's gravity. Inside the shell, the planet's 8 worlds threaded across billions of kilometres of empty space. You could hide 1,000 Earths in the gaps between them and never notice. Let's drop toward the centre. And there it is, the Sunday. 1 million Earths would fit inside it, and it holds more than 99% of everything in the solar system. Yet, among the galaxy's hundreds of billions of stars, it's completely ordinary. The biggest worlds are the gas giants. Jupiter could swallow more than 1,300 Earths, and its great storm is wider than our whole planet. Saturn's rings stretch most of the way from the Earth to the Moon. Speaking of which, here is the Earth and its Moon, 384,000 kilometres apart. That gap looks tiny from here, but it's wide enough to line up every other planet in the solar system side by side with room left over. Closer. And this is home. 12,700 kilometres across one pale blue dot. And so far, the only place on this entire journey where we know for certain that something is alive. Drop to the surface. Everest, the tallest mountain there is, climbs almost 9 kilometres. And yet, next to the whole planet, even that is just a faint wrinkle on a smooth blue sphere. And down here, at last, we find something new. You. About 1.7 metres of restless, walking, tumbling stardust, pacing back and forth, turning the occasional cartwheel, somehow alive. After all those impossible distances, here you are, standing on one small world. But don't get too comfortable, because we are only halfway. It's true. On a scale that runs from the largest thing we know to the smallest, living things sit almost exactly in the middle. You are about as far from the edge of the universe as you are from the tiniest speck of reality. So let's keep going. Not outward now, but inward. Zoom past your skin to a single grain of sand about a millimetre across, already smaller than the letters on this screen. And to what's coming, a grain of sand is a giant. Smaller. One living cell, 100th of a millimetre. Far too small to see. And it's no simple speck. Each cell is a roaring city of molecular machines, building and repairing millions of times a second. Smaller again. A single bacterium, a couple of micrometers long. 1,000 of them would fit across one human hair. And right now, more of them live on and inside you than there are stars in the Milky Way. Keep falling. A virus about 100 nanometers. We've just shrunk past the wavelength of visible light, which means no ordinary microscope can ever truly see one. To go deeper, we have to leave light behind. Inside every cell waits this DNA. The double helix is just 2 nanometers wide, but unravel the strand from a single cell and it runs about 2 meters. All the DNA in your body could reach the sun and back many times over. Down along the strand, we reach single molecules. Here's the simplest water. 2 hydrogen atoms holding on to 1 of oxygen. Just 3 atoms. We're nearly at the floor of chemistry. And here it is, a single atom. 1/10 of a nanometer wide. For thousands of years, this was the smallest thing anyone could imagine. The word itself means uncuttable. Everyone thought this was the end. It isn't. Because the atom is almost entirely empty. About 99.9999% of it is nothing at all. If the atom were a stadium, everything solid inside it would be a single marble, sitting at the very centre. And there's the marble, the nucleus. 100,000 times smaller than the atom around it, yet holding almost all of its mass. To reach it, we cross a vast emptiness. The nucleus is built from smaller things, still protons and neutrons, crushed together about a femtometer apart. A quadrillion of them would fit across a single millimetre. Slip inside a proton, and you find quarks, 3 of them, bound so tightly they can never be torn fully apart. They're so small we've never measured any size at all. As far as we can tell, they're simply points. The same goes for the electron, far out at the atom's edge. It seems to have no size whatsoever, a pure point, carrying charge and mass, taking up no space at all. And at last, the floor. The Planck length, about 10 to the minus 35 meters. The smallest distance that means anything. Below it, the very ideas of space and length stop working, and reality may dissolve into a churning quantum foam. We can fall no further. So that's the whole staircase from the observable universe to the Planck length, 60 powers of 10. Galaxies, stars, planets, you, cells, atoms, quarks, every one a single step on the same ladder. And look outward or inward, it never seems to end. You spend your whole life at one comfortable scale, right near the middle. But you're built from the smallest things. You live inside the largest. And you're made of the exact same stuff as everything else on this ladder. You aren't separate from the scale of everything. You are part of it. So look up and look in. It's all one.